Hello, everyone. Thanks for having me here. So my name is William. I'm Brazilian, and I'm Mozilla Tech speaker, and I work for eBay. I like to play video games. I'm big at Monster Hunter for fun, so if you want to talk about Monster Hunter, sim racing games, or football, please reach me out after this talk. Before I start my presentation, just a small disclaimer. All the proposals I want to show here are under construction. The main intention here is to give you a sneak peek about the future of JavaScript and try to help you to understand the use case and the pros, the cons, and of all of these features, and show the amazing work that the C39 community is doing to improve the language we love. Some of these features may or may not be present on JavaScript. If you like one of these proposals, if you have some concern, or if you want to express your support with some of these proposals, please use this link below and open issue, put a star, and get engaged. So the agenda for today, we are talking about parent matching, pipeline operator, binary AST, and I'll give some opinions. So whenever you see a red border in the slide, it's just my opinion. If you disagree, just ignore or talk to me afterwards. That said, so to give a background motivation of the first feature, I want to talk a bit more about a conditional in JavaScript. Nowadays, we have only 3 ways to do conditionals in JavaScript. We have if-else statement, switch statement, and ternary expression. Just to set a common ground to everyone, an expression is something that evaluates down to a value, and a statement is just something that does something. So an if-else statement requires a condition, which evaluates to truthy or falsy value. If the condition is true, it executes the adjacent block, and if it's not, it tries to execute the else block if you have one. But it can get complicated. Let's check it out. For this section, I'm using this simple function that just tries to return emoji that tries to reflect the current temperature. As you can see here, this function, it's just an if statement that if it's true, it just returns the emoji. But else statement, it's again another if statement. So this is a way to concatenate and chain one if statement after the other. It can get really tricky because I'm not even talking about nested if-else statement, right? For this kind of special checks, when I have a lot of options and a small code to react to, I think switch statement is a handy tool. So let's check how switch statement works. So if statement is it's good whenever you need to react to a couple of choice, or you have a lot of chunk of code to execute. But when you have multiple choices and just a small set of commands, I think switch statement could be a good choice. The switch statement works as the following. Given an expression inside the parentheses on the switch, it tries to match with each one of these case statement. And when it matches with the first one, it jumps. That's the starting point of this block statement. And then that's why we have the break statement just to finalize the block. So coming back to our initial example, this is how we would write something using switch statement. There are 2 things I want to highlight here. First, I'm not using a break statement because just by using return, I have my function stopping at that line, so that's why I don't need to use break. And the second thing is, people may not get it, but the case statement accepts expression as well. So I can put, instead of just a constant, that this is the most used use case there, you just put a constant and you put an expression and switch. So then I swap, like I use the constant in switch, and I use the expression there. So the ternary operator became popular recently because for the functional developer fan who try to write the code with as much expression as possible. It basically works as the following. Given a condition, if this condition is true, it runs the first block after the question mark. If it's not, it's false. It runs what we have after colon. And since ternary is expression, we can write that function using arrow function, and that tries to make everything more concise. But then you have a code like this, and I don't know if you like it or don't like it, but there are a lot of people that like this kind of code. I'm not here to judge, I'm just showing you. And as you can see, we have 3 ways to do conditions nowadays in JavaScript. But what's the matter, the fourth one? Could you imagine what could happen if you mix if statement with switch statement and the power of the structuring pattern? Pattern matching. To understand how pattern matching works, I need to use a toy example to be able to explore the pattern matching statement. So let's suppose I have a list of shapes, and I need to log and detect all the circles, red square, and big blue triangles. How could I do this nowadays with if statement? Just to give a small context, this is the sample entry, and this is one of potential solutions for the problem. It's tricky because it can grow as the requirements grows, right? You can put if in there as the more you have further requirements. And this is how we can do this using pattern matching. Because of the time here, I will just explain the core concepts. And if you are interested in it, you can either check the documentation on the GitHub repository or talk to me afterwards. This is the case statement, which defines the start of the pattern matching block. It receives only one value as input, and this value is called case expression. Then we have the when clause, which is divided in some parts. I will just show 2 of them today. Again, you can have more in the spec in the repository. Okay, in this first when clause, we have it split in 2. Like the first part before the arrow is the match pattern, and the second part is the when clause body. So the match pattern will execute the body whenever the shape of the pattern matches the shape of expression. In this case, every single object that has the type of circle. And then to achieve the second use case, I can just create another pattern, which is type square, color red. And in this step, you see a if statement in the middle. This is called match guard. It means that even though the match matches with the object, if the if statement, which is called match guard, returns false, it will not execute the block. And the last case is whenever we have a standalone variable, it matches everything. So it's kind of the full statement for switch case, but a bit different. Checking our initial example, this is how we should work with pattern matching. It's nice. And if somehow we saw this talk before, this would be the part that will start to complain why pattern matching is a statement. But then the DC39 committee just changed this. So parent matching in all languages is an expression, and being a statement in JavaScript will be tricky because it will be difficult to decide whether to use parent matching or just a bunch of if-else statement. But then if now that parent match is just an expression, it becomes a powerful tool as a substitute for ternary expression. And now they are trying to ask us if we need to have the when in the beginning of the when clause, or we just need to use a let const or var. So to give an example, this is the way they're discussing that the syntax may look like. Do you like it? You don't like it? Do you have a better idea? Again, go to the repository and comment there. OK. Before introducing the next proposal, let's check how function composition, what is function composition, how it works in JavaScript nowadays. So function composition is a mathematical concept that allows you to combine multiple functions to create a new function. So to help you to get the picture, let's cook a bento. I came up with this example because it's easier to reason about food, and I like to use emoji. So this is just a function that creates a bento following a sequential series of steps, and where the next steps needs to receive the result from the previous steps. So in this case, to achieve this, I need to have these intermediary variables just to hold the data to pass to the next function. But I don't want to use these intermediary variables just for this, right? But I can go and write this kind of code, which is not so easy to reason about because the more we compose, the bigger is the indentation we have, and the way we read the code is different the way the data flow, because the data flow from the innermost function to the outermost function, and we read this data usually top down, left and right, right? But I can use low-dash flow for achieving a similar effect and make this more readable, or use Lambda pipe for this, or even create my custom vanilla JavaScript function. So wouldn't it be nice to have all of this capability somehow incorporated to JavaScript without having to rely on this external library or create custom homemade functions? So let's bring the second JavaScript proposal of this talk. Pipeline operator. So pipeline operator is a syntax sugar for creating streamlined chain of function in a readable and a functional manner. It's backward compatible and provides alternative for extended building prototypes. So our initial example was written like this snippet, but using pipeline operator, this will look more like this. And then this will be the sugar to this. It's nice, right? But what if one of my chaining functions needs one extra parameter? Let's suppose that the add fish function needs to receive a second parameter, which is the type of fish I want to add to create my nigiri. How should we add this to the pipeline chain? So to achieve this, we can wrap this function with an arrow function. So then we receive only the result for the previous step, and then add this to the next step. Note that in the minimal propose, the arrow function has to be wrapped with parentheses, otherwise we will have a syntax error. But a bento is not only about nigiri. We need to put some stuff in it, right? I know how to do nigiri. It's kind of just like smash some rice and put a fish on top of it. But it's simple, but I just realized that I don't know how to assemble a bento. And I need to somehow delegate this to another function. I just figured out that I don't know how to assemble the bento. So I will delegate to this to an async function that will create in the assembly the bento for me. But how can I do this using pipeline operator? It's tricky, right? I could use a wait to await this function, but there is a problem in it. And note that the line 4 is ambiguous, and I'll explain why now. Um, if the implementation add bento, it's just a straightforward async function, I want to have this line distributed to the line 6, like this one. But if I have an uncommon implementation which behaves like a factory that returns me a function that I need to call, passing the nigiri to create the bento, I would like to have this line be distributed to this line 6. The problem is in the minimal proposal, there is no guarantee that I can that await step could be distributed neither to the line 5 or 6 or 3 or 5. As you can see, the minimal proposal has some caveats that we need to address in order to have this proposal progress in the TC39 proposal pipeline. Currently, we have 2 competing proposals that tries to solve this in different ways. So I want to explain first the smart pipeline proposal. So as you can see here, this is how I could solve this using smart pipeline. And you can see that we have 2 styles there. Whenever you have like just a straightforward functional call, you use the bar style. And whenever you need to do like passing extra parameters or user weights or use this in a different way, you can use topic style. There are some rules. Whenever you need to use parentheses and square brackets, you have to use topic style. Otherwise, you have a syntax error. And the sharp you saw in the previous step, this sharp token is just the placeholder for the result of the previous step. And it's not finally sharp. It's subject to change. They discuss if the sharp token is the best way. OK, if you have a create function, you have to use topic style. Otherwise, again, you have a syntax error because you're using parentheses. This proposal has extensive documentation for further enhancements over this core proposal. Again, check that out and see what you think about it. And as a counterpart, we have the F-sharp proposal that tries to address this ambiguity of an async function using one thing called await step. It seems simpler, but still we need to wrap, whenever we need to use extra parameters, we need to wrap this function with an arrow function, and still we have the overhead of have these parentheses there. But this could be solved on a further proposal. So just to summarize, it's a nice addition to JavaScript to create a streamlined way of composing functions. The minimal proposal has 2 caveats. The smart pipeline tries to solve that using a token, and the F-sharp tries to solve that using a wait step. Which brings to my rant. My point is, I really, really like pipeline operator, and I want to have this shipped to JavaScript as soon as possible. So then I have a proposal here. I think F-sharp proposal is great, and since it only extends the minimal proposal with the await step, I think we should try to ship this as much as possible. Then afterwards, we could have another proposal try to address the usage of the sharp token or not. Nevertheless, Bubble has a plugin for using smart pipeline proposal. You can check that out and use on your to play a bit, and then you form your opinion. Okay, before we go into our last proposal of this presentation, I would like to mention some performance tips. Have you ever heard about any of these JavaScript performance tips here? Do you ever wonder why they are so important for the perceived performance of your application? So to understand these practices and understand why they are important and why our next proposal is related to that, we need first to check how JavaScript engine generally works. To roughly explain how the JavaScript works, I would show this. I would use this illustration that I borrowed from an excellent article from Anders Money regarding the startup performance of JavaScript. So whenever the browsers find a script tag, they try to download the text content of it. Then it tries to parse this text content and the result of this text content would be abstract syntax tree, or AST, which is a tree representation of your code. And then after this AST is done, the browser starts to compile and create the bytecode. So this last part is regarding runtime optimization that the browser does to make the JavaScript execution faster, but this is not the targets of this presentation. Okay, to put in short, JavaScript lifecycle could be described generally as download, parse, compilation, run, optimization, de-optimization, and garbage collector. But here I want to focus on the parsing phase. Why? Thinking about the code startup in JavaScript, we can see that this is crucial for the perceived performance of an application. So to make an application start faster, we end up doing those things I mentioned in the first slide of this section. But one thing doesn't change, the parsing time. Parsing the initial compilation of JavaScript can take up to 30% of the main thread time. And 1 megabyte of uncompressed JavaScript can easily take a whole second to be parsed in an average mobile cell phone. Normally, the browser needs to parse the whole file before start compiling it. And these are the motivation for the last proposal of this talk. Binary AST. The binary AST proposal proposes a new over-the-wire format for the JavaScript based on the binary representation of a custom AST. This could potentially decrease the code startup of a large JavaScript application, and the browser that doesn't support it just load the normal JavaScript file. So this is how it may work. First, you need to write your beautiful and delightful piece of JavaScript. Then you compile it or bundle it. Use your best flavor of bundle to spire you like that provides such a feature. And this process will give not only the min.js file, but it will give you as well the binary representation of your JavaScript file. So the browsers that support this format could have the parsing dramatically decreased, since the majority of this task is done in build time. So the champions of this proposal create a POC on SpiderMonkey using the JavaScript JS engine. And they try to compile some JavaScript into binary AST and measure the performance. And this is the following outcomes. The result was the following. They used the static news feed from Facebook, and the size of the binary AST was slightly smaller than the original JavaScript. The time for create the AST from plain JavaScript was between 500 and 800 milliseconds, but the time for create the binary AST was twice as fast as before. So the POC showed some evidence that shipping plain binary AST was a good performance win. And the extra annotation that the binary ASTs will have can enable that code elimination without relying on plugins such as tree shaking. And this annotation could improve to the point that it's possible to enable stream compilation. And if the performance of this hypothetical stream compilation was close to the current WASM WebAssembly string compilation, we can reach to the point that the compilation time for your JavaScript using this binary AST could be faster than the download time. So you can start your application right after downloaded. Amazing, right? So these are further read for you if you want to check that out. Like there's plenty more information in these links. These are my links if you want to reach me out. If you want to follow me on Twitter, I don't tweet so much, but when I tweet some JavaScript tips. And that's it from me. Thank you.